Hello friends, this is Durga again from Technology Mentor / ITversity. As part of developing MapReduce applications using Hadoop APIs, we have seen many things so far, starting from simple MapReduce applications using default behavior and also record count. We have gone ahead and developed a MapReduce application following the complete life cycle. And then we also see how to write custom keys and custom partitioners as part of that, sorry, custom keys and custom values as part of that. And also lately we have seen how we can implement filtering while doing the MapReduce application. And now we will get to the next topic, how we should how the data will be partitioned. First we'll see how data is partitioned in MapReduce, and then we will see how we can actually change the behavior of partitioning. So in the previous application, when we ran the average stock volume per month, that data is all scattered. Let me show you what I'm talking about. I will be running the MapReduce application which we have developed so far, and we will review the output, and then we will see the current behavior, and then we will talk about what are the issues with that behavior and why should we change it, and then we will see how should we change it. So for that I am running this Hadoop jar command, and I would like to filter on Bank of America and Apple. Filter.by.stock equal to BAC APL. And hit enter. This will just take a moment to execute. I am rerunning it because the filter condition is wrong. It should be stock ticker, which I have changed, and the output file is 03, and hitting enter. So it will just take a moment. So now it is completed, and let us review the path. Let me copy this output path. And if you see fs-ls, there will be 4 files here because we are using 4 reducers. And if you cat on these files, so there is no proper order here, means everything is scattered. For Bank of America, in this it has 2012 March, 2012 July, 2012 October, and again for 2013 also some random months. So there is no proper grouping of this. Like that, all the 4 files will have the information which you are looking for, but a little bit scattered. It might make more sense if we can group all the Bank of America stocks together, or all 2012 January stocks and January data together, February data together. If we can achieve that, it will make sense. Okay, but here it is all scattered. For example, 2012 March Bank of America is in this file, and 2012 March Apple data might be in some other file. So either you should group based upon stock ticker or month. It will logically make more sense than having the data all scattered like this. So for that, we don't need to write any complex programs. We should be knowledgeable enough about partitioners, and using these partitioners and understanding how we can tweak, we can actually achieve the behavior we are looking for most of the use cases. That being said, let's go back and revisit how the entire flow works once again. So you have the data in a HDFS, and then when you try processing the data, there will be map tasks like this, and for each record the map task will be invoked. So if we have 52 records in a file, and then the map task will be invoked uh, uh, in our deck of map task will be invoked 52 times, once for each record. And as part of our map task, we have the logic to transform our data to the tuples like this, so that we can do the count downstream. I'm talking about our second program or third program, which will do card count by suite, and the output of the mapper will look like this. And then this shuffle and sort phase kicks in, and data will be partitioned as part of the shuffle and sort process. So there are three things: partitioning, comparing, and also combining if you use combiners. But whether you use combiner or not, partitioning and comparing will definitely work. And by default, partitioning happens using hash algorithm on the keys. In this case, the keys are spade, club, diamond, and heart. And then a mod function will be applied using number of reducers. In our case, number of reducers is 2. Hence, the hash value of spade, club, diamond, and heart is divided by 2, and based upon the remainder, it has decided to distribute data in this fashion. Spade has gone to one partition, and club, diamond, heart has gone to other partition. So this is where partitioning comes into picture. And coming to our data, our key is custom key, which is text pair, which have 2 text fields. And the logic of hash for our custom key is driven by, if you go to the key values package, where we have created the custom keys, and for text pair this is the custom key. And if you remember, one of so when you actually develop custom key, you have to implement writable comparable interface, due to which you need to define behavior for 3 methods: read fields, write, and compare to. On top of that, we have also overridden methods like hash code from object, equals, and also toString. So for partitioning, hash code is highly relevant, and because, as I mentioned to you, hash function will be applied on the data, and that hash function is nothing but this one. Whatever logic here is used to compute the hash function, and then it will apply the mod by using number of reducers. So to understand that, let's go ahead and look at the partitioner, hash partitioner. I'm going to the grep code, and here I can say org.apache.hadoop.mapreduce.partition.hashPartitioner. And it is part of the Hadoop MapReduce client core package, and I'm clicking on the latest one. If you see here, there will be a method called getPartition. Okay, I think it is looking at the wrong one. Let me get the package name, the correct package name. So for that, so by default it uses the hash partitioner. Okay, so after map, we can set it anywhere, but logically partitioning happens multiple times after the mapper or during the map function invocation. So there is a method called set partitioner class as part of job object. You can set hash partitioner here. And this is the path which we have to look into. So we'll see this logic using grep code. What is the logic that is implemented using this class? Okay, it seems it is not changed from the beginning. So anyway, so this is how it looks like. So for example, you already have get partition in this hash partitioner, and again this hash partitioner extends a class called partitioner. Okay, and partitioner is an abstract class, and there is no definition for the get partition method. It's just an abstract class. Okay, and here we are defining the behavior. So what it says is to compute the hash code on the key. So our key, whatever key we pass, it will compute the hash code. So if it is text pair, it will compute the hash code for the text pair, and that is defined as part of our text pair hash code. So whatever is defined here, that will be in effect, and then using integer.max value, it is doing bit operation, I think, and then it is doing the mod num reduce tasks. So whatever number of reduce tasks you have passed while invoking the program. So in our case, we have invoked using 4. So for the keys, for our keys, which is the combination of transaction traded month as well as the stock ticker, it will compute the hash code using the text space hash code function, and then it will apply the mod 4, and depending upon the remainder, it will divide. So in this case, the way the data is divided is that all these keys, hash value mod 4 has given the remainder 0. That's why it went to the first first file, and for the next one, for the next file, if you cat and hit enter, you can see that all these keys have the hash value of these keys mod 4 has given remainder 1, and there are only a few of them, unlike the previous one. And this one has fewer of them, so you can even see the size and determine. So it is not evenly distributed, but they are not significantly different also. Anyway, that is not the primary concern here. The primary concern is to understand how the data is being partitioned. So for each of the keys, which is a text pair in our case, hash value will be computed using the hash function, which is defined as part of our custom key class, and then mod number of reducers will be applied, and based upon the remainder, data will be partitioned into multiple buckets, in this case 4. That being said, now let us see how we can actually tweak this and try to change the behavior. You can change hash code function here to play with the behavior. You can go and write a custom partitioner also by extending partitioner class and providing functionality for get partition method described in the partitioner abstract class. And also there are predefined partitioners on top of hash partitioners. So far we are using only hash partitioner, but there are other partitioners also. So let's go to Hadoop API and see what are they. Hadoop API, click on this one, and then search for Partitioner. Again, these italicized ones are the old API, and these ones are new API. You can click on the one which has the new API, and you can see that there are 4 types of partitioners. One is total order partitioner, which is a little bit complicated, and I will cover later. So it is relevant when we talk about sorting. And then key field based partitioner, hash partitioner, and binary partitioner. So binary partitioner is to partition the binary data. So you can go to this and understand the logic. I have never used it, so I'm not 100% sure how to use it, and probably I will not cover binary partitioner, but I will try to cover all the 3 by the end of the course. Key field partitioner is pretty straightforward. So right now our key is a object of type text pair. So we have written a custom class to deal with all text pair all composite keys which have two texts or two alphanumeric fields in them. And the same thing can be developed without creating this custom key. By just using text as the type for our key, we can actually build a comma separated or pipe delimited key as part of our program. So there is no need of custom key all the time. But in our case, to modularize the code, we have created the custom key. But is it mandatory? No. For our use case, especially to store the traded month and the stock ticker, you can use the text itself, which can store the string values, and use a delimiter between them. So if that is the case, if the key is of such sort, instead of using custom key, if you are using text itself to using delimiter, then you can use this key field based partitioner, and you can determine on which part of the of your string should be used to partition. For example, if you have a three field string separated by comma, so by using a key field based partitioner, you can set a couple of configuration parameters to read a particular field out of the string. So for in this case, let's say you have traded month and the stock ticker. If you want to partition by stock ticker, you have to pass couple of fields, and then you can say that okay, partition by the second field. Or if you just want to partition by the first field so that all the records for a given month are grouped together, you can do that also. Let's go ahead and see the code of it. You will understand pretty easily. Okay, you can see here. So this num key fields for partition will tell you how many keys you are using, how many key fields you are using for partition. So in our case, if we represent our key of traded month and stock ticker using a delimiter like comma, then the num key fields for partition should be passed just 2. Okay, and then there are other parameters also which will be used. So this one, map reduce partition key partitioner options, and you can tell which field it should read from, and there is a class called key field helper. Using this one, it will actually read those configuration parameters, and it will try to apply the logic. So let me so here you can see, so you can say what is the begin field index, what is the begin character, what is the end field index, what is the end character. So there are many things which you can use to tell a particular field to be used to partition the data. So it is pretty handy when you have scenarios like ours, where you need to have a composite field, but you are not using custom keys, but instead you are using pre-existing keys itself. Then you can use this. So you might have a question, why then we have created text pair? So text pair is created because it is more readable, and you can actually customize quite a few things pretty easily because it is more modularized also. And also, second reason why we have started working on custom keys is that for numeric types, if you are using key fields partitioner, even for the even for that, you have, even for the keys which are having numeric values, you have to define in the test text. So it will not make much sense if you are dealing with other types also. So for that reason, you have to be aware of custom keys, and you should be able to write the custom keys like we have done in the last video. Anyway, that's different story. Right now let's focus on the partitioner. And so far we have seen what is partitioner, how it uses hash code internally for default partitioner and partition the data, and what are the predefined partitioners. In the next video we will start tweaking the behavior by playing with hash code, and also by writing our custom partitioner as well. That being said, I hope you are enjoying the content so far on my channel. If you like a particular video, please click on the like button. And if you want to post a comment or ask me a technical question, leverage the comment section of the video. If you have not subscribed to my channel yet, please do so. You will start seeing a lot more content than just Hadoop or big data. Thank you. Bye.